All right, we're ready to go. We're going to be doing some Python PyTorch today, some activation functions. Let's get our, we're going to look at all the different activation functions. We're going to get back into it. We've been doing some JavaScript for the past few weeks, and we need to warm back up with some PyTorch. Let's get it going. All right, so let's say XOR.py, and this is my favorite. I don't know if you guys have ever written a hello world with PyTorch before. XOR is my favorite because you have all the data. Hey, Spider-Moon Toby, good to see you. Welcome on in. Hey, Torva, good to see you. Hello. Yo. All right, you guys. We're back into Python now. We're going to be building AI for the next few weeks. ... All right. Dun, dun, dun. All right, good to see you guys. Python. Why did it say npx? What? Hold on. That was unusual. Nice. What? I know, right? What? Woo. Okay. Good news. Good news, you guys. Back into the Python. So we're going to do import torch. And we're going to have our X input. And I believe it looks something like this. 0.0. This is my favorite. I don't know if you've ever done PyTorch Hello World programs before. My favorite is the XOR. This will be the XOR, you guys. XOR right there. Right there. All right. Nice to be back to Python. I know, right? We're back. How's it going there, Sachin? Rot. Good to see you. Welcome on in. Happy Monday. You love Python? Me too. It's the language for AI. So we're back on the Python now. Hey, Developer Exotic. Good to see you. Welcome on in. Happy Monday. All right. So I believe it looks like this. 0, 0, 1, or 1, 1. You could do that, right? Might as well. Or you could also do 0, 1, and you also want a 1, 0. So you cover all the bases. This is why I like XOR. Because all the data is right here. It's right here, you guys. Yep, Spider-Moon Toby. You did it. Spider-Moon Toby, you're number 1. Thank you for the hearts and reactions, you guys. Good to see you. Happy Monday. All right, so believe this will be a 0. Is it 0? Is it like this? Is it 0? Is it 0, 0? I believe it's like this. I'm pretty sure. Thank you for the reactions, you guys. All right, lots of party poppers and smiley faces in there. Some floaty heart icons. All right, let's get everything lined up nice and clean here. I like to line everything up nice and clean. All right, like this, and 1, and this will also be a 1 here. All right, perfect, you guys. All right, so now we got our data, 100% of the data. We're gonna be doing activations. We're doing activations today. All right, let's get the next song going here. Where's that at? Here, around here somewhere. One of these things here. Where did it go? Oh, well, let's do this one. Here we go. Perfect. Okay. All right, let's get going. Yes, Spider-Man Toby is first today. I'm learning Swift. Hey, Swift, all right. Swift is great. Is better option than Flutter. I think it's pretty good. I think it's a pretty good option. You're thinking becoming a specialist in iOS app dev. Hey, there you go. Verticalize. Yes, if you have a specialization, you're on the right track. All right, so what do we need to do next? All right, let's look at our notes over here. All right, we've defined our X and Y. We need to convert these into tensors. Torch.tensor. And we need a D type equals. Hey, Steven. Hey, how's it going? You're Avi. Welcome on in. Hey, Steven, can you deep dive into Visual Pipeline Builder? I'm confused about this topic. Maybe you know about it. Do I? What is that? I don't know what that is. What is the Visual Pipeline Builder? I guess what we could do is look it up. Visual Pipeline Builder. What do we got here? Well, I figured it was going to be very generic. Drag and drop interface used to design, manage, and automate data workflows. I don't know about this. You got to give me more details. There's a lot of data pipelines in the world. There's a lot. There's not just one. There's not just two. There's a bunch of them. There are a lot. Torch.float 32. Is that right? Did I do that right? I don't know if that's correct. D type. Let's try this. All right. Is that correct? Let me review my notes. D type torch float. Yeah, we figured it out. All right. All right, let's build our model next. All right, so this will be a class. We'll call it our XOR model. And then oh wait, so torch. We need to import a neural network. I think we just say torch.inn. I'm pretty sure we could do this. Let's find. If we can't do that, we'll do something different. We'll figure it out. Okay. I just sent the PDF in the LinkedIn. Please, can you take a look? PDF? I don't know about PDF. PDFs have considerations from a security perspective. What are you trying to do over there? It's better if you send a link. If you send a link, or Google, you can even send me the link to Google directly. Like say, here's what you search for in the keyword to find it. PDFs, I'm being cautious here. I'm super cautious about this. Like I hardly run code. If you send me like a random repository link, you're like, hey Steven, would you run this code? I'm like, nah, not gonna run it. No. PDF's got embedded scripting languages and can have some scary things happening over there. A little bit of scary things happen. And it. All right, this was self, I believe. Okay. I don't know if we. Yeah, let's do super self XOR model self. This is annoying that you have to do this, by the way. It's really annoying. Hey, Savan, good to see you. Back to Python. Yep, exact. Okay, I'll share the link. Sounds good. A link is better. Yellow, all good to see you. Oh, what do we got on over here? The gate of, you are saying Phantom Witness? They have the eyes to see. What are you talking about? World's alive? Oh, I don't know what you're saying. You're concerning me. You're concerning me over there. All right, so we're gonna have a linear. So this will be the input layer. Input is gonna equal torch.nn.linear. And because the input is gonna be size of 2, because the amount of parameters or sort of features, right? The number of features in our model needs to be 2. So we're gonna say 2, comma, and then the density. How dense? Density equals. We'll say 10. Let's say 5. Density. How about this? How about instead we say units? You might be familiar with this. Great to be here, Savant. Nice. Hey Steven, did you ever run sudo rm-rf / do we ever do that? No. Delete everything command. I like that one. You ever got to run that one? Like the delete all command, right? Sudo, because and it's really gonna get everything. Hi, how long? Hey, Drunk Brothers. Hey, good to see you. Welcome on in. Long time no see. You got it. We're back in the Python, you guys. Self dot output is gonna be 1, right? It needs to be a 1. It needs to be 1. So let's see here, and I believe we're gonna say units, and then 1, like that, because the output's gonna be 1. We have Claude for that now. We sure do. We got Claude to take care of all the things now. It speeds up everything in the. Sure will. It'll speed it up to infinity. Torva, it will. Infinity speed, because now it doesn't do anything. It'll work great. Even more than downloading free RAM. You're right, it will. Hey, Marco, good to see you. There's a typo in linear. Oh, hey, you're right. There is. Thank you. Let's type it. Linear. Is that better? I like it. Marco, I like how you say there's a typo in linear, and you should look what it was before. Linear. It's like not just a little bit of a typo, a very big, completely big typo. Thank you for spotting that. I wouldn't have noticed it right away. Appreciate it, Marco. Thank you. Awesome. All right, let's get a poll going. All right, so what's your favorite AI framework? All right, we're only going to give you a few options. We're going to say Keras, TensorFlow. Here, this is what I'm doing. I'm typing some stuff here. All right, Keras, plus TensorFlow or regular, or do like PyTorch. And then I'm going to be biased, and I'm going to put some bias indication here. Just a little bit of bias indication. What's your favorite? What's your favorite framework? All right. So let's get going over here. We're going to say, all right, so here's what we're going to do is we're going to have our activation. Activation equals, we're going to start with sigmoid, torch.nn.sigmoid. Okay. Why the wig? Oh yeah, no, my hair's exactly right. I just got a lot of fluff in it. I've got a lot of fluff in it right now. Good to see you there, Salt Trek Tom. Good to see you. Welcome on in. What are we building, Steven? We're going to work with all the different activation functions today. We're warming back up after being off of Python for half a month. For being off of Python for half a month. What is the BG music? It's not a match for this type of content. I know, right? It's the... All right, we can go to the next one. How about that? Is that better? It's a little bit more upbeat now. A little bit more upbeat. Hey, I just dropped into the link on LinkedIn. Please check it out when I get a chance. All right. You're Avi. We'll check it out on LinkedIn. All right. Hey, Celtrek. Lie. All right, I know, right? I've got a lot of hair stuff in it right now. Hey, I have an idea. Coding platform after pressing the submit button. If it's not accepted, then fa sound. Yeah, I know what you're saying. I know the fa sound. Yep. Should be played if accepted, and then yay sound should be played if it is accepted. How can we do this? I don't know. You gotta let me know when it happens. None of them work with Mogul Bogle. I know. Torva someday. How's it going there, Bros? Good to see you. Hello. Steven, good to see you after some time was inconsistent someday. Oh, you're all good. Glad to have you here today. All right, let's do a self.activation equals our activation so we can update it later. All right, so now we've got an input and an output layer and our units, right? So essentially we got 3 layers. We got an input layer with a hidden layer, which is gonna be the units, and then the output layer going through the hidden units to a 1 on the other side. Seek the Vault, good to see you, welcome on in. Happy Monday, hi. Anyone can help me out, guys, with the fa sound effects? Well, there is a sound effects, what's it called? All right, here, I know what you're talking about. All right, 1 second. I've got it here, 1 second. Oh, hey, I saw your message come through. Avinish, I saw it. I see it here. On LinkedIn. All right, 1 moment. Here we go, you guys, 1 moment. All right, and let's go to, how do we do this? Where's me? Here we go. Okay. It's called, all right, let's pull it up. My instance sounds. Okay, here we go. There we go. There's the one. Now the fa sound. Like, yeah. What about the yay one? What's the yay one? I don't know about that one. All right, there we go. Between those two. All right, we got sound effects. I know about the sound effects. All right, let's pop this back over to our terminal window. All right, Manny, it's not hard to just add a line to the compiler that plays a sound before putting up the errors running code. Hey, Neva, that's a really good idea. Oh, I didn't even think of that. That's great. Neva's got the ideas, you guys. Neva's got the ideas. Value all backgrounds and identities. Safety. No hate speech. Oh yeah, Savon, thank you. Yep, discussion ideas. Exactly, Paul. You got it. All right, let's keep going, you guys. Hey, Neva, we're back to Python. And you just pop back in. Yep, we're getting back into Python and some AI now. We're doing activation. We're warming back up after being on JavaScript for so long. Like I'm talking about the Leet Code platform could be able to do that. Yes, you can. It's called, what is that? There's a mod that you can install as an extension. It's some sort of a script extension for Chrome. I forgot what it was called. So like monkey patching script or some monkey script. Monkey script Chrome extension. Let's see, what's Tamper Monkey? There you go. Here you go, Tamper Monkey. So what you do is you get Tamper Monkey. You install this, right? So you can install it into Chrome. Install Tamper Monkey. That allows you to update any web page that you're currently on, including leak code, right? Then you program in when the test pass, you look on the page to see if there's an element that shows that you succeeded or failed. Then you play the fa sound or the yay sound, depending on your success. There you go. It's called Tamper Monkey. Do the Tamper Monkey. Yeah. There you go. Oh, yeah, easy. Yep, you got it. Easy. Yeah, there's an extension named fa, which plays the fa sound whenever there is an error in the code. It's a good one. Thank you, guys. Yeah, thank you. I like that. All right. So before we go further, I'm going to take a look at the LinkedIn real quick. Because, here we go. Wait, not this one. Where was it? Was it around here somewhere? Okay, 1 second. Let me bring it up on another window real quick. Let me bring up on another window real quick, you guys. Pull this over here. Go into my messages. Okay, here we go. All right, Avanish. Okay. Love to understand the concept through your live stream. Hope the next stream is going to cover this topic. All right, we'll take a look here. Oh, you sent me a ChatGPT link. I don't know if I could do that. I'm going to try. I'll try. It might say no. Oh, no, it does. It works. Okay. Okay. Let's see what you got here. Okay. Vector Shift Pipeline Builder. Complete detail. Okay. Nice. All right, we're taking a look now. We're taking a look. Better not, right? Better not. I don't know. Wait, what is it? What do you mean better not? Vector Shift Pipeline, complete detail. This project is a visual pipeline builder. Think of it as a Zapier end-to-end workflow automation. Okay, so far I get it. Understand. Looks good. Drag and drop, connect them, run, and then backend checks if the structured valid. Shift to the and certificates. Oh, check the certificates. What do you check out? Oh, check. Yeah, right. Exactly. Yeah. So this, I believe, is it. Okay. Let's check the certificates. All right, we're gonna check them. Site is secure. Connection. Certificate is valid. ChatGPT.com. Looks fine to me. Google Trust Services. Oh, wow. No way. It's good. The ChatGPT is... I didn't know this. Did you guys know this? By Google. Who knew? Who knew about that? That's crazy. Yes. All right. We're good to go. Good thing, Savon. Always double check. You got it. All right. Visually create pipeline like this. Okay. Run it. All right. What are we doing here? There's a lot to go through. You're just having me read the output from an AI. What do we got going on here? A bunch of different nodes. Yep, looks good. So are you just talking about general pipelines? I think you're just talking about general pipelines. Looks like that looks good. Styling. Captain, just doing my duty as mod. Thank you, Savon. Appreciate it. Hope you're okay over there. Lots of things going on in the world. Verify some sort of graph is not complex. We've got to verify them complex graphs. Why this project is strong. Oh, so you're, okay. Draw the complete architecture diagram. Explain how to implement a DAG. Is it dicyclical something? What is DAG again? Acronym. Direct acyclic graph. Okay. Been very tough. Oh, that's terrible to hear. That's not good. Okay. You're already right here. Directed acyclic graph. 2 days now, relatively quiet. Finally. Oh, good to hear. All right, a little bit better. Graph with no cycles, like why compiler. Oh, what compilers have. Got it. Okay. So, from if you're still watching, if you're still watching Avanish, then from my understanding, you're looking to build something similar to a pipeline workflow based on what I'm reading here, and the AI is giving you the instructions on how to go about this. How's it going there, John Deere? Good to see you. Howdy. Welcome on in. It's like a tree, also a node to have two parents. It's like that. Is this? Oh, got it. Right. Okay, gotcha. The dicyclic. Diacyclic. called directed acyclic graph. I've carefully gone through your full PDF and now I'll explain everything in detail. Simple language, step-by-step, complete architecture front end. Okay. Vector shift pipeline builder, complete detail. It's like Zapier in it in. Yeah, all right, so it's just a workflow. If you have any questions, let me know. Here, I'll send you a message on LinkedIn real quick and we're going to get back to our Python. Because it's pretty, what you just showed us is very straightforward. It's very straightforward. Okay, let's keep going here. Where is this at? So around here somewhere. Here we go. Okay. All right. Thank you for the hearts, you guys, the reactions. Let me know if you have any specific questions, and we'll answer them on stream or here in chat. Okay, there we go. Oh, wait, I just want to know that it's a React project. All right, sounds good. And I got this to work on. You are a front-end developer. You're stuck. What the meaning of the pipelines? It's just a step-by-step process, right? It's a step-by-step process. And it usually in an in or Zapier, they let you define what each step is from the end user perspective, right? And then each step has a guaranteed input and output that the next step can understand, unless you want to break one of the steps and cause an error or end early, depending on the conditions. So I think it's pretty straight. I think it's pretty simple. It's a pretty simple, easy to understand. Just wanted to thank for your positivity. Oh, love to have you as a companion while coding in the evening. Hey, Marco, that's great to hear. Thank you. It was really good feedback. I appreciate it. I appreciate it very much. Thank you. All right, let's keep going, you guys. I'm gonna make some just organize this, make it look a little bit easier to see what's going on. I like to line up my equal signs because it makes everything organized. Pipeline is just a list of functions. Hey, Neva, there you go. Keeping it simple. Just a list of functions. All right, let's go to the next phase here. All right, where are we at now? We want to, all right, so we got to define our forward def. Forward. And then we need to push everything through each of these. Or don't we need an input? We need an input. Input F1, F2. Yep, exactly. Exactly. The thing about days is that it defines dependencies. This is exactly syntax for a pipeline in Elixir. Oh, it's the exact syntax. Oh, is it really? With a pipe like this. Okay. Pipe arrow. Was it pipe? Right. Oh, that's a triangle right there. If I ever saw one, look at that. That's really neat. Look at that, a triangle. I've never used that operator before. As you can tell, I have not written much Elixir, which is as important as the functions themselves. The order. Yep. The thing about the dependencies. You got it, you guys. You got it. You got it. All right, let's keep on going. All right, I like this operator. I would like to use this operator in Python, please. Actually, sort of not really. I don't really need it. It's not necessary. All right, let's keep going, you guys. All right, so I want to self.input. So let's see, out equals, I think this is how we do it. Out self.input. Oh, yeah. All right, we got the input there. And then we've got our, what would be nice is if we just automatically moved all of this into sort of a linear structure. I forgot, a sequence. It's sequential. I think we can do it with the sequential. X pipe greater than F means take pass the first argument to F. X goes to the first argument of F. It makes some code very clean, similar to what x.method does. Oh, very nice. Okay. Hey, Sky0198, good to see you. Welcome on in. Happy Monday. We're doing some PyTorch today, you guys. Good to have you here. Welcome on in. All right. The cyclical is just formalism for order and disambiguity. Oh, we're learning we're using fancy words. I like that. We're using fancy words. Can I do a sequence? Self.sequence equals torch.nn.sequential. Is that how we do that? It's been a while, so I don't need to worry about the inputs and outputs anymore. Let's do this here. No, please. Yep. Thank you. Indent. Appreciate it. And then we're going to go like that. Indent this and do some commas. All right. There we go. I'm pretty sure that works. I think maybe. We're going to find out. All right. Let's pull this window up here. Okay. Self.sequential or sequence and then input. And I think we just return that. I think return, right? Is that it right there? Did I do it right? I'm trying to remember. Too much of your lecture word verbatim. Useless skills here in French words. Oh, I think it's useful. Psychic graphs can be ambiguous, like in C templates. For a DAG, they can be ambiguous. Ambiguo? Is that what you're saying? Did I say that right? Am I pronouncing? Are you saying ambiguous? I'm thinking you meant ambiguous because the X is right next to the S. Too much of my professor words. I meant from university. Yeah, I like those big words. I like them. They're fun. Okay, so I'm pretty sure that's enough. Here, let's open this up. Python. Let's see if it at least runs. All right. Wait, what did we call this? Oh, XOR. Okay. Let's make sure this boots up. Okay, sequence input. Takes at most 2 parameters. All right, how do we do sequential? I'm missing it. I'm late. Hey, no worries. You're on time. You're good to go, Martins. You're good to go. Jide Martins. All right, let's see here. PyTorch. Let's remember. Sequential example. I forgot how to do this. All right, how do we do this? Self.sequence. Did I type that right? I didn't even spell sequence right. SEQUENCE. Let's spell properly here. So you're supposed to say spell properly is what you're supposed to say. nn.sequential. I'm just looking up the docs real quick on this. Yeah, I did it right. How do we use it? Do we just say that? No, we can't do that because that's the forward method. That's forward. That's forward, right? Model equals. Oh, the model itself. 1 second. Hey, Steven, how's it going there? Nathan Mycroft, good to see you. Welcome on in. Something you wrote and actually meant lifetime forces a PL to rank 1 type polymorphism. Oh, we're getting all fancy words here. Well, lifetimes inside closures force rank n types. They can still be monomorphized over generics. All right, Neva, I think you win. You win. Got an illustrative example there, Neva? All right. Update to use sequential model. All right, sequential. All right. I want to do this approach. I'm pretty sure that's correct. I'm pretty sure. I feel like this is right. Okay. Okay. Oh. All right. I think this is good. So we need to change this up. All right. So if we're gonna do sequential, here, what we're gonna do is we're gonna undo everything. If we're gonna do sequential, we're gonna do it differently. So I'm not gonna worry about that right now. All right. Let's just get going here, like this. We'll do sequential later. Return out. Okay. Self.output. This is activation. I'm pretty sure we could do that. I think that'll work. Let's see if that works there. All right. Dependencies are supposed to be non-ambiguous, otherwise it's impossible to execute as an airflow, for example. That statement says lifetimes hard, lifetimes closures very hard, but can still be made into go vroom. Can be made go vroom or go run. The statement says lifetimes hard, lifetimes closures very hard. Well, I can tell you, I like to not have to deal with those lifetimes. I really do. I like not having to deal with them. All right, I'm pretty sure that's fine right there. I'm pretty sure. All right, let's see if that runs now. All right. Oh, model takes oh, what? Where? What line? Line 9? Right here? What do you mean? What? Oh. So from torch import NN. 1 second. Let's see if I can figure this out, you guys. See if I can debug my business over here. Okay. I don't need this. I'm just doing it wrong. Module. There we go. There we go. Now we're figuring it out probably. Is it going to work now? Or is it going to... Yep, there we go. All right, we figured it out. Easy. Dependencies on dependencies on dependencies depend on dependencies. Hey, Jinlu, good to see you. Welcome in and happy Monday. We're going back to Python. We're getting back into AI. We're doing the AI thing. And we are warming back up with some activation functions. And then we'll eventually get into a project. And then we've got some fun We've got some plans for next week. We've got some plans for next week, you guys. All right. Okay. I like this. We're looking good here. So, model equals, is that model or model? No, yes, I had it right. Model equals XOR model. I think. Let's double check that works. All right, still working. Looks good. Not a problem. Okay. Right. Okay. I'm happy with this. I think this is fine. This is fine. Okay, let's keep going, you guys. And then I've got my... Looks so good. Okay, so now we've got our, what you call, essentially, a model for XOR. And it's really forgiving. It's very forgiving. You can type a whole bunch of you can type this different ways. You can use different approaches. And what we're going to do today is we're going to play with a bunch of different varieties of activations. That's the plan for today. A whole bunch of different activation varieties. All right. So let's keep on going. All right. Let's look up some of the options we got here. All right, so PyTorch list of activations. Let's see here. What do we got? I would like to take a look at all of them. There we go. There we go. Is this? Oh wait, there's no way. There's way too many. These are not These are not activations. Non-linear activations. Here we go. Other softmax, soft minimum, softmax 2-dimensional, log softmax. Look at those. All right, so we've got a hard shrink, a hard sigmoid. Ooh, a hard sigmoid, you say? I want to graph that. I like to graph that. I'm going to like to see this. We've got GLU, applies the gated linear unit function. Some threshold, tanh, soft sine. I am very interested to look at all of these. I want to see each one. And we're doing the sigmoid right now. And I also like tanh. Those are also good. Hey, YouTuber. Good to see ya. Welcome on in, YouTuber. Happy Monday. I wanted to ask if there are any front-end development opportunities in your company. I'd be happy to contribute and support the team. All right. So I will give you some information on that right now. Even a trial or internship basis. All right. So those of you who are new here, let me bump the music here. Is this a good one? I'm trying to find the right song. This is fine. All right. So my name is Stephen Blum. I'm the CTO at PubNub. We've raised 134 million Series E, 1 billion devices, 68 patent claims granted. Yes, they're real patent claims. We are powering your games, all of your media and entertainment. We're powering multiplayer experiences, telemedicine, e-commerce with live auctions and bidding, fintech with the live stock ticker quotes and updates, call centers with chat messages, and transportation and logistics. We have a section down here at the bottom of the screen called Careers. You click into that. This opens up our career page, and it gives you a list of all of our current open roles that we have right now. Pubnub.com/careers. You got it. Exactly. So there you see, we currently we don't have any open front end roles at this time. I will post it on Discord though. It will come on Discord. We will open up any role that we open up. We'll throw on Discord. I will open up over there on Discord. Send you guys a link. There, ChatGPT graph all of them for you. Yeah, never exactly. We could ask ChatGPT to graph all of them for us. We could, or we could hand type it ourselves and take 10 times longer. Do you guys want to take 10 times longer? I think so. That is what we're going to do. We're going to take 10 times longer. There cannot be a cyclical dependency, hence making a pipeline never finishes if that is the route. An infinite loop! Infinite loop! Okay, so that's our current opens. Our current opens, you guys. Let's keep going. Good to have you here. All right, so I do believe I want to... So now that we've got our XOR model, I want to go... I want to graph each of them. I do. So let's get a list of all of our activation functions here. Okay, let's copy and paste this. Grab all of these right here. Copy. Paste. All right. Did we do that right? Is that correct? Yeah, that looks pretty good. All right, that's a lot. There's a lot in there. All right, let's look through this. Dot. Whole bunch in here. At least that's what my professor said. Oh, right. Okay. All right, looking good. GLU. All right, NN. All right, so let's do this. Like that. Let me go. Let me go S / beginning / torch dot / G. There you go. So that's a list, and then we should also update it so we say our activations equals. We got a full list, a whole list of activations here, you guys. And then S / the end / comma. Add a comma to the end of those. There we go. Got our syntax proper. All right. Activations, current activation. I think that looks good to me. All right, let's make sure our syntax is still working good. Yeah, is it working? Yep, yeah, we are. We're looking good. Would you waste cycles in solving a cyclical dependency rather than prevent it from the first place? I like how you guys are going back and forth on the semantics. I guess we're talking about different things. Are you guys? I don't know. All right, let's close this window here. Okay. Okay. So we've got a nice list of activation functions. I didn't know there were this many. What's tan shrink? What's threshold? I've not used all these. I've used tan H. I've used sigmoid and relu. I've heard of log sigmoid. That's pretty obvious. Leaky relu. I've used that. What are all these other ones? Look at this, you guys. All right. So what we should do is we should graph each of these. I don't recognize 3 of those. You don't? Well, I don't recognize all of them. All but 3. We're in the inverse. On the inverse. We're going to check them all out. I don't even know. When do you use all these? Why waste performance on it at all? Hey, you're asking the right questions. All right, let's keep going. So, now that we've got a giant list here, let's at least get our model training here. So let us get going. So our delta equals torch.nn.binary cross entropy loss. Is that right? Delta. Okay. How's it going there? Roanna? Good to see you, Roanna. Welcome on in. All right, 1 second. I think we need to okay. Thank you for the hearts, you guys. Good to have you here. Appreciate the reactions. We don't need to do... We just only import Torch. That's all we do. Torch import. Optimizer is going to be torch.optim, I think. No, we need to actually specify an optimizer. Which one should we do? We should also do, oh, right, Adam, W, model.parameters, learning rate. It's gonna be LR equals learning rate, 0.1. I want to flee the market. Yesterday, I bought a bunch of 4-part MacBooks. Did you? Jinlu? Hey, Data, welcome on in. Thank you for subscribing. Happy Monday. You joined the right channel for software engineering. We talk about AI is what we're going to be doing. For the most part, we spend a lot of time on Python and AI. A lot of time on Python and AI. A whole bunch of time. And we also did some JavaScript the other last 2 weeks. So, so a little bit of JavaScript there. And programming language for sure, especially in Python. Rust prevents it, which JavaScript, where its strength lies, the borrow system, the borrow checker, the good old borrow checker, yeah. Hey, you went to flea market yesterday and bought a bunch of parts. Oh, the flea market, that's what it is. You can do that. MacBook, usually everything's like soldered onto the Mac, right? They're all soldered in. What kind of parts did you buy, Jinlu? Is it original or like new parts, like the M series MacBooks and stuff like that? Rust for sure, cyclical dependencies. It's unrelated to borrowing. Ah, okay, yeah. Have you sent photos in general chat? I want to see. Oh, look at that. All right, so we got ooh, yep, I guess it's some old generation MacBooks there. I can see, I recognize the connectors. That's a pretty good haul from a flea market. Does it work? Do these work? Oh, it sure does. Look at that. It boots up. Oh, that one's got a problem. Just a little bit of a broken screen problem, not a problem. How many? Yeah, exactly. How many? I count. I don't know if this is entire, but 1, 2, 3, 4, 5, 6, 7, 8. This looks like an error, like an 8 in there. How much RAM is that? I know, right? Nice stash. Yeah. I broke a screen. Oh, no, you did. It's actually a 2016 MacBook. Well, those are still pretty good. I think they're pretty good. Nice haul. Yeah, exactly. You're doing good there, Jinlu. All right. So we got our optimizer. And then we need to optimize what we got to do. All right. So now that we've got all of our hyperparameters and everything set up, we got our model. Now we just run it through a for loop. The number of epochs. Epochs. We'll do 100. Okay. Then 12 or 13 MacBooks. Are you serious? Also some random Windows laptops in there as well. Did you just buy it? You're like, I want that one and that one and that one. And you bought them all. That's great. Good job. All right, let me check my calendar, guys, real quick. I want to make sure that I am on the right pace here, because I do got some meetings coming up. Okay, so we got about 40 minutes. We're good. We're good. About 40 minutes. Linux on everything, or are you just gonna make a work with Mac OS? You could. Can you tell me which code editor are you using? Yes, I will. All right, so at UR-Obby. This is Vim. Yep, you got it, Sivan. You beat me. Plus tmux on ghosty. Yep. Yeah, so this is the Vim text editor right here. The Vim text editor 9.1.1752, which is just the version that came pre-installed on my Mac. It just came pre-installed. I didn't have to do anything special. Not sure about some of the other ones. Oh, you did? Staying on macOS because it seems to have been patched with OpenCore. Ah. Oh, Steven, you made me start using NeoVim. Oh, really? No way. That's great. You use it the opposite reason to use NeoVim. Oh, Vim. Wait, you use it the opposite reasons you use. Oh, wait. Okay. So my reason to use Vim is because I like it. It makes me happy. So are you saying the opposite of that? Is that what you're saying? You like it because it doesn't make you happy? Wait, what? Is that, are you serious? All right, so we got to do 4 epoch in range epoches. Print epoch. All right, let's see if that works out. What are you doing? How's it going there, Pamit Michael? Pamit Mitchell? Welcome on in. Good question. We are currently going through all of the available activation functions in PyTorch, which turns out there's a lot of them. Look at this. Look at all these right here. There's so many. Well, we're just going to scroll up there for a second. I can't believe how many there are. And that's just the nonlinear ones. There's just nonlinear ones. Oh, looks cool for left, right, up, down. Yep, exactly. Vim, you got it. Hey, you're Avi, you know it. Vim does support this in VS. Yep, you can do Vim mode in Visual Studio Code. In VS Code, you sure can. No, you use the LSP. And not the motions. Got it. You like the language server protocol. Got it. Understood. We're learning all about it. Okay. More we know, you guys. It's really nice bindings to LSP motions. You can customize it. Nice. So yeah, that's the plan. So we're going through the activation functions right now. We're going to make sure that we've got a nice toy model set up and ready to go. We're going to test out each of the activation functions, and then I want to graph each of them to see what they look like from a linear perspective. We're going to get matplotlib going. We'll get some matplotlib going, guys. It's so exciting. I'm getting excited for matplotlib. Okay. So let's make sure this works. Print epochs looks good. Okay. Looks good to me. There we go. Okay. We need to get our prediction will be model, and then all of our data. So here's all of our x's, right? All our x data. So this is x equals features, or the input, the training input. Training input. So, what else? There's other words for this. And y equals the labels, or the output / answers, right? Essentially, the answers. Spell perfectly. Love your energy. It's really seriously inspiring. Well, thank you. Appreciate it. It's great feedback. Glad to have you here. Answers. There we go. And these are the questions. The questions. There we go. So you got the questions and you got the answers. That's basically what AI is, right? You ask the AI question, it gives you the answers. Right here, right? The input. Features, input, questions, labels, output, answers. They're all the same. They're all the same. It's all the same, you guys. All right, keep going. We're not done yet. Okay. I want to predict all the data, and we'll say print our prediction so you can see what's going on there. And it's just going to give us a bunch of random numbers. I'm pretty sure. I'm almost nearly certain it's going to give us a bunch of random numbers. Let's try it out. Syntax error. No problem. We can fix that. Yep. A whole bunch of random data. Check that out. Okay. Paste in Discord about your acyclical graphs and pipeline validity. I'm kind of curious. What do you got going over there? In general, you said? YDAGs are essentially for workflow ABD pipeline sustainability. All right. What is this? What do we got here? Is this the right one? Did we do it right? Is this it? Oh, wow. There's a lot to this here. In Airflow, dependencies can be identified between tasks within a DAG, right? And across different DAGs. Tasks with a DAG can be linked using simple bit shift operators. Wait, no, wait, really? Oh, look at that. Explicit methods defined with their execution order. By default, a task runs after all of its upstream tasks have succeeded. T0, T1, T3. All the way, skipping T2. Set downstream. T3 set downstream. Oh, neat. Okay, we're learning a little bit more. For complex dependencies, the chain and cross downstream functions can be used to chain tasks sequentially, making every task one list depend on every other task in another, respectively. You gotta add the respectively in there. Thoughts on future of tech? Good fella, welcome on in. Good to see you. Happy Monday. Future tech's going to be interesting, isn't it? We're all building everything. Everyone's an engineer now with AI writing code for them. We're all engineers now. So we're going to see an explosion of creativity. An explosion of creativity, you guys. So much creativity. I'm trying to improve leak code. What rating range are you at right now? And how long did it take you to reach there? I've only done leak code occasionally and not from a score level. I've not really scored much there. Future tech's going to be interesting though, isn't it? I think it is. I think it's going to be interesting because everyone can write code now and build whatever they want to build. Creativity is going to explode. You took a video of you sorting and fixing all the MacBooks. You did? We'll have to take a look there. From a leak code perspective, you guys, where are you at on leak code?
Pro. This means it's a Pro. It's having GPU issues, and as far as I can gather, the dedicated Radeon graphics in this thing just died. However, I should just be able to disable those with NVRAM, which I did up here.
All right.
It's waiting on the keyboard or trackpad. I don't know what's happening.
So you've bypassed the dedicated discrete, or you're trying to enable the discrete GPU.
Oh.
Oh, is that good or bad?
There we go.
Hey, that's good.
Now it's normal again.
It took a while to restart. Ah, got it. All right. Hey, very nice. So you restored the dedicated GPU somehow. I don't know how you did that. Good job. That was great. Very nice. Nice. All right, let's get back to our code, you guys. The Radeon graphics were cooked, so I forced it to use only the Intel graphics. Got it. Okay. That makes sense. There was a time when a non-developer used an external platform to show their portfolio. Now they're just dropping their own website using AI. No, yep, you just, hey AI, write me a website portfolio. Okay, here you go. Your portfolio is ready for you now. You can present this to your employer. Your future employer, they'll be impressed. Okay, I want to, all right, let's do this. So we got our loss equals our delta, predictions, y, right? So we're gonna see how far it was off, Loss dot, so we have to optimizer, we need to clear grad backward and then step. Okay, let's try it. Let's make sure it looks good. Got to spell correctly. Delta. Okay. Hey, look at that. All right, it works. Is this correct? Yes, it is. Yes, it is. That looks great. Okay. You guys might not, I mean, those of you who are in the know, you'd be like, oh yeah, that definitely looks good. Because it's an XOR. Okay, so what we want to do is make it look a little bit nicer. So can we do torch dot, is there torch dot round? Can we do that? Torch dot round? Is there such a thing? Or is there does that work? It does? Yeah, it does. All right, perfect. Excellent. So that will put it out on the right answer. I'm actually kind of curious to see if you do a full linear activation, if we round it automatically. No, I think that would it cause a problem? I don't know if that would cause a problem. Let's try it. Out. Hey, Jinlu! Your song just started playing out of nowhere. It must have been on a playlist. The only downside of a rapid growth of AI models is that RAM and SSD prices have increased. I mean, is that the only downside? Yeah, I bet you can find more than one. I bet you might be able to find more than one downside. You want to probably tell it something like round 3, so use more than just one, or P, where, well, torch.round out. I'm curious to see what it's going to do, if it's going to learn or if it's going to fail. It fails. Yeah, it fails. And it's either 1 or 0. I was messing around. I mean, obviously that wasn't going to work. Maybe. Okay. Let's keep on going. All right. So now we have something that works. So we've got a guaranteed system that is perfectly working at 100% accuracy. Success, you guys. Round has no gradient for obvious reasons. Yep, you can't backpropagate that. You cannot backpropagate it because you lose everything. It's a full total loss. That's a good point, Neva. It's all gone. You can't get it back. All right. So I want to, so we got some time left here, you guys. We've got some time left. All right, let's keep going. We're not done yet. So here is all of our non-linear equations. Equation. Hold on. 1 second. Oops. Shift plus Y. Okay. Looking good. Steven, how does loss know which weights to downgrade? In PyTorch, yes. There's a hack make to be like linear used some papers with round plus x minus x dot detached. Oh, okay. Still round x, we pretend the gradient is just x. Okay. That makes sense. Got it. That's okay. So we can, you're right. Okay. In that case, if we want to do backpropagation with round, we could just say the original is going to be the original output before x. I mean, the exact x before rounding it. That actually makes sense, and it probably would work too. How does the loss know the weights? All right, so it does all of them. It does all of them. It compares all of them in the graph, I think. So we do that right around, where's that at? Here, right here, in the optimizer for the graph. So you've got the loss, which is obviously that's easy, right? That's really easy. You've got your predicted outputs, which is what the model thinks the answer is. And then you've got your actual answers and Y. And then you compare the two, and then you get an answer, right? Print loss. There you go. Whoops, I've been in JavaScript world for too long. Hello, Steven. Hey, how's it going there, Facecam? Good to see you. Welcome on in. There are many downsides to AI, but only a few people know how to turn them into opportunities and keep growing. Yep, you know it. You know it. That's the way. Loss isn't special. It's just the fact we calculate gradients. Loss is pretty straightforward right here because you just calculate the output, and the output is going to be, or the delta from the output and the actual answer. That's really all that is. And then you can run loss backward, which is going to give you access to, since it's got your prediction. So you can see it's a tensor, right? When we're printing out the prediction will link back into the model weights. So that way, you know, when you optimize, right? When you run the optimizer, it will be able to back propagate through all of your layers. It's like a link. It's got a full link. It's like a graph. So it edits in place. Yes, it sure does. You're right, Savannah. It sure does. So let's print our loss now. Sweet there. Nice little loss going on there. Yeah. Loss is very high. And then suddenly it learns everything. Suddenly it learns. It's like, oh, hey, no, I understand. Let's add 1,000. So that way the loss goes to 0. The loss should approach near 0. Pretty close to 0. Yeah, it's pretty close near to 0. Yeah, this is like diminishing returns after a while. What happens if we add another layer? Let's do another layer. Let's do another layer. Input 2. We'll go units. Then we will say the same thing here. Input 2. Just like that. What does it look like now? Oh, error. No, wait, that should be fine. Why is that working? Oh, input. There we go. Nice. Oh, hey, it learned a lot better that time. Look at that. I mean, relatively speaking, right? Yeah, it was an order of magnitude better. Does it really matter? No. No, it doesn't matter. Not even a smidgen. Okay. So now that we've messed around with this enough, let's get to drawing some matplotlib. All right, so I want to do a simple, all right, let's see here. Matplotlib, simple linear graph. Wait, is there a terminal-based graph? I kind of want to try it. It's something outside of matplotlib. All right, terminal-based line graph. Python. What's the best library for that? Do you guys know? Do you know what a good? It's called plot text. There's a couple of options here. Which one should we use? Which one should we use, you guys? Okay, let's look here. We've got plot text, and we've got ASCII and term graph. Let's take a look at some of the images. All right. This is pretty nice. I like this one right here. I came across your email and saw the GIF instead of a profile picture. Oh, you did? I really admire your curiosity and willingness to explore everything. Yeah, if you didn't know this, on Google, you can upload an animated GIF or GIF. A GIF. You can upload one and it will use it as your avatar. You can do that. All right. Which one do I like? Which one looks good? I kind of like this one. What's this one here? This is Uniplot. Interesting. All right, let's try Uniplot. Uniplot. Okay, so Uniplot Python. Uniplot can refer to two different tools, Python integrated. Uniplot is a lightweight Python library designed for plotting directly in the terminal using Unicode and Braille characters. Hey, that's what we want. Pip install Uniplot. Let's do it. All right, how do we use it? All right, NumPy, and we'll use NumPy, and then we'll plot. Okay, let's try it. Let's try it, you guys. Let's try it. Let's see what it looks like. This is exciting. All right, import Uniplot. Let's see if we can run. Is it import? Does it work good? Yes, it sure does. It sure does. Reminiscent of sine cosine waves? Yeah, you know it. 41 people are watching and only 17 guys like. Please double tap the screen. Oh, you're Avi. Thank you for saying that. Yeah, appreciate having guys here. Enjoying watching. Matplotlib is good too. It sure is. It's pretty good. I want to get into I want to be fancy. I feel like I want to be fancy today. I want to do it directly in the terminal window. You're in the Discord because we have a mod chat for organizing and stuff. That's true, Torva. Thank you for mentioning it. We sure do. All right, this is great. All right, so we've got an X and a Y. So what I'm going to do is X and Y. Oh, this is easy. Oh, that's easy. That is easy. All right, plot. Okay, let's try it. So let's remove the print there. And I want to plot the, where we have here? A range, rand. Okay, good. Let's plot the loss. Let's try to plot the loss. All right, so losses is an array. Epochs. I'm just going to say, we're just going to do this. Make it easy. Epochs. And then we will print. No, not print. We want to uniplot dot plot our epochs and our losses. And we say losses dot append loss. There we go. I think that'll do it. Hey everyone, Sergio, welcome on in. Good to see you. Happy Monday. We're back to Python. We're warming back up with PyTorch. We're getting back into it, and we will be focusing on maybe a project eventually later this week with some PyTorch. And then next week we'll be doing some more AI stuff. So we're back to the AI stuff, you guys. We're back to the AI stuff. Merciless. Hey, what's merciless? Oh, that's your username, and there you go. Jen in the back. All right, fed the cats. Nice. Gotta feed the kitty cats. I think we did it, you guys. I think we succeeded. Let's see if it works. Oh, no, we got a problem. We got a problem there. Self.return numpy. Oh, wait. Oh, let's see here. Loss. So can we say, is a loss dot numpy? Can we do that? Do we have to say that? Does it have to be numpy? No. Detach. Detach? We're trying to remember all the things here. Is it detach? Nope, doesn't like that. Well, loss is just, so hold on. When I was printing the loss, it was a tensor. So it is a tensor. So we do have to CPU. Can we do that? All right, 1 second. Before we plot, because that seems to be where the problem is. And then also we need to say, this is the losses. Let's do print losses. See if that looks good. Let's see if it's right. Detach is a function you need to call. We do need to call it? Okay. I figured. All right. Detach. All right, let's try that. That's still a tensor. Dot numpy. Okay. Let's try that. Let's see if that works. Let's see if that works. Okay. Oh, almost. Plot takes from 1 to 2 positional arguments, but 3 were given. Well, because it was right here. Oh, title. Okay. Title equals. All right. What's going on here? Hello, world. It's good to see you. Happy Monday. What is this project? We are building a simple hello world in PyTorch just to ramp. We've been doing JavaScript for the past 2 weeks, right? For almost a month, a half of a month. So, hey, Bobo Bear, good to see you. Sorry, I've been not here much. Hey, no worries. Hope you're having a great day. We're having a very good day. A very good day indeed. We are building an XOR sort of hello world, getting back into PyTorch and Python, resurfacing all those memories that we've had from the past 2 weeks. We're doing a lot of JavaScript, you guys, a lot of JavaScript. And now we're back into some Python. And we'll be doing a lot of AI. So that's the plan. The plan for the foreseeable future right now is AI stuff. We've got a nice plan for next week and the week after that. Some neat things happening. Thank you for the hearts, you guys. Appreciate it. Detach CPU numpy. All right, we'll do that. CPU. There you go. All right. It's a no-op if you don't need it, but it's perfectly fine. We all can use a break from JavaScript too. I love it though. Hey, there you go. Is C harder than C# and C++? Well, it depends on what you mean by difficulty. Learning the language of C is actually pretty straightforward because there's only about 25 or so keywords to memorize. Not a lot. You can easily do it. And you'll be able to build anything you want in C and it'll be very fast. The problem though, you can build a thing that doesn't work and it will crash. You can do that. Chanman21, thank you for subscribing. Welcome on in. Good to have you here. We do a lot of computer science stuff. We don't use the AI to write our code. We do use the AI to help us look up things and learn a few things. C is simpler but harder. Yes, exactly. C is simpler but harder. I like that. Neva, excellent explanation. What's your favorite language? Mine is JavaScript. Nice. Yeah, so it's between JavaScript, Python, and Rust. Those are my favorites. JavaScript, Python, and Rust, you guys. All right, see if that works. Is that going to work? And there it goes. Look at that. All right, we did it. Oh, looks good. Although it's weird. It's kind of weird. All right, maybe what we could do is reduce the learning rate. Let's reduce the learning rate so we can see it look prettier. We did it, you guys. Hello, world. Rust. Yeah, we love Rust there. You got the crab icon there. All right, so learning rate is going to be much lower. Let's drop that. All right, there. Look at that nice, pretty little chart we got going on there. All right, here, I've got a better idea. Let's close this window and we'll open up a new one. And we'll just say Python XOR. Oh, hold on a second. There is a backtick file. Hey, look at that. Look at that file right there. We must have done something. I created a file somehow. Golang is the best language ever. Golang is also great. I've been using some Golang recently. We'll see. It's pretty easy to get to know. The system interactions and so on take some time. Also, it's old, so not as many features. Yep, concurrency, you got it. And so on, Torva. Great explanation, Torva. Thank you. Rust is so cool, like the only thing. All right, you guys, we've got a new poll happening here. I know what we're gonna do. What is your favorite language? And you only get to choose the ones that I pick. All right, here we go. Your favorite heart language. All right, and it's we're gonna say JavaScript. We're gonna say Python. All right, Python, or we're gonna say Rust. We're gonna add a few more. Don't worry, we're gonna add a few more. We're gonna add a few more. Hey, Corey Jeffries, thank you for subscribing. Welcome on in. Happy Monday. Can we do more? Or we can only do 4. Okay. Other. You can't. I can't add any more. I can't add any more. All right. So other, like Java /JVM /Golang Swift / I don't know, Erlang / Haskell. Oh, it's too big. It's too big. Okay. There we go. All the other ones / Haskell. There we go. Oh, too big. Too big. Okay, there we go. Amia, thank you for subscribing. Welcome on in, Attias. Good to have you here. Happy Monday. We do a lot of software engineering here. Good to guys have you here. So good to have you here. C#. Oh, I forgot about C#. Lisp? No way. No one would ever say Lisp. JS includes TypeScript, right? Yes, it does. Yes, it does. TypeScript counts. Best programming language is when you make a VM, create an assembler for it, create a high-level language for it. Your own language. Is that what you're saying, Facecam? Write in your own language? RM / backtick. All right. Whoops, I created a file. Did you know you could create a file like this? You can create a file like that. Who knew? You shouldn't, because it's weird. All right. Python XOR. Hey, there we go. Look at that. Nice, pretty graph right there. That's what I'm looking for. That's exactly what I'm looking for. I like it. Think for the party, but Mogul Bogle, crying face. I know, there's no way you could ever possibly. Malbogle. JavaScript is winning. It makes sense. Hey, Redless Saber, welcome on in. Good to see you. Happy Friday. Oh, wait, it's not Friday, it's Monday. Whoops, I'm already ready for the end of the week. Look at this. This is great. This is really neat. I like this. Isn't it weird how it learns and then it just suddenly learns rapidly? Probably because the optimizer, the Adam W optimizer is what's going on. Fortran. Oh, I got another language in there. Favorite language, Fortran. Ooh, Python, you guys. Oh, C. We forgot about C, right? Facecam. Steven is already done with the week. I know, right? We're already over. All right, we got a little bit of time left here, you guys. Let's keep going. So let's actually lower their learning rate just a smidge more. Another factor of magnitude there. And see what that graph looks like. See if we can make that graph. Hey, it looks more linear now. Look at that. All right. That's what I like. That is what I like. Although, did it learn enough? I don't think it learned enough. If the learning rate was too small now. It's too small. What happened? Coffee machine broke? What happened? No, we're good. We got plenty of energy. We're all happy. By the way, it's pronounced Malbolge. Wait, hold on. Malbolge. Is like J or G? Are you G like Y? Malbolge. I think Malbolge, right? Malbolge. No, Python is winning. Oh no, Python's winning, you guys. San Andreas scripting. If you know that language, is it? They have their own dedicated language. Why wouldn't they choose Lua? I think Lua would make a lot more sense. Diving into the programming world, nice. G like GIF, or GIF, GIF. G GIF. Zero help. Hey, thank you for the jewels there, You said a marshmallow. I love liberty, justice. Thank you. Appreciate it. Thank you for the jewels. Oh, what up, man? Soki, good to see ya. Good to see ya. Zero help, like G like GIF. Malbo. Hey, what we're gonna do is we're gonna go to translate. We're gonna say over here, detect language. Actually, we'll say English. I think maybe. We'll find out. You say Malbolge.
Malbolge. malbulge, 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 malbulge,
Malbulge.
malbulge,
Malbulge.
malbulge.
Is that right? Are we saying it right?
Malbulge.
Is that right now, Torva?
Malbulge.
Like the G from green, right?
Malbulge.
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 Yeah, we learned it now. Malbulge. I've been calling it mogul bogle.
Malbulge.
I like calling it mogul bogle better, but malbulge.
Malbulge.
Jython. Hey, Big Mike. Jython. I love Liberty Justice again. Thank you for the marshmallow. Appreciate it. Good to have you here. You did some front-end work today. Can I send a screenshot? Absolutely. Send a screenshot, you guys, on Discord. Feedback on the design. Let's do it. Screenshot, you guys. Also, Lua is working on GTA San Andreas multiplayer. Nice. Good to hear it, Lua, you guys. Sounds French, isn't it? Maybe it is. Wait, does it sound like an actual French? It actually might be. It might be. Is French... no, it's not French. It's an American-created esoteric programming language designed in 98 by Ben Almstead. Peter Piper pickled a peck of pickled peppers. Let me look on YouTube. All right, sounds good. All right, so we've got our beautiful, beautiful drawing skills here. So let us draw every single one of these. Let's draw each one of these now. I want to do this. All right, so let's just S / nope. The beginning of the line with this. There we go. Turn that off. Or you know what? I've got a better idea. We'll just say def train, and then we'll indent it and not call it. That's what we'll do. We'll leave it there and we'll just not call it. There we go. Okay. Let's do a def print all activations. So this will be the plan. Once we achieve this objective, when we print all activations, we're good to go. The Peter tongue twister. It is the Peter tongue twister. You got me pretty good. Peter Piper picked a peck of pickled peppers. I'm trying. Yeah, like GIF from Malbolg. GIF. Yeah, like from GIF Malbolg. It is? Sent it, Soki? Okay. Hey, we got Cade. All right, Cade's there, you guys. All right, let's take a look. Hey, this looks great. You prompted a user interface here. Check this out. All right. I do like it. Okay. So it's pretty common, pretty standard. System prompt, user prompt, run the models, model output, evaluation, evalues, requirements met. What's this? What's requirements? Why assign epoch for the for loop if you're not using it as a variable in the loop body? We were printing it. I suppose you could just say underscore. Is that what you're looking for? Do you want it to be underscore, Adam? Is that what you're thinking? Just make it be underscore? Is that better? Are you gonna live stream AI for weeks? Yes. Yep, Adam. All right, there we go. It's better now. Underscore. You got it. I like this UI. It's great. Optimization configuration. Use judge model. What's the judge model? Is there a judge model? Are you doing multi-step? That's for system prompt optimization. Oh, very nice. Okay, so what you can do is it's an LLM eval platform. Excellent. Got to evaluate. You got to evaluate. Got it. Which one's better? You got to say which one's better using the winning model. Model evaluations, model outputs. Got it. Run all models. Figure out which one's the right one. This is a great UI. I like it. Clean, simple, easy to understand. It looks good. It looks good. There's also something up here called display or deploy. What's the deploy button do up here? See, I don't know if you can see that. You can't see that on stream. There you go. Right here. It says deploy. What is that? What's deploy? Soki. What is that? All right. We're going to print out every activation function available to us as far as we know in PyTorch. That's what we're going to do right now. That's from Streamlit. Oh, you don't know? All right, no worries. All good. Oh, I already got it wrong. She sells seashells by the seashore. That one's hard, Jinlo. That one's difficult. You got a difficult one there. All right. So we are going to plot everything. All right. So we're going to do a range. How do we do a range here? Let's do this real quick. Python. Can we do range 0.0 to 1.0? I don't think that works. Do we say step 0.1? Something that... Oh, I know what we could do. I've got a better idea. Okay. We'll do 1,000 and we'll just divide by 1,000. No, we should do 100. 100? Maybe 80. We'll do 80. Okay. The X equals range 80. Like that. And then Y equals NP import numpy. After a week, which project you want to work on it? After a few weeks, which projects you want to work on it? Is that another tongue twister? I don't think. Facecam, probably not a tongue twister. So we've got a plan. We're going to be building more AI. We're going to be building an AI project. I would like to do some more computer vision things. And then we'll go into Kaggle, and get some of the data sets, and we'll look at some ideas to train some models, and we'll build some models. Maybe some visual stuff, right? Something that would be interesting. We'll figure it out. It'll be fun. That's the plan. Let's print every single activation function. Let's do this, you guys. All right. NumPy.range. Can we do this? Is this something we can... You know what we could do better is array. And we say range. I think that's probably fine. We'll validate. We'll validate real quick. What do you like to use AI for? A lot of different things. A whole bunch of things. I use AI for everything. Everything, you guys. 100%. Make a model that turns any picture into a picture of Obama by rearranging the pixels. Jinlu. All right, I'm going to copy and paste that. I like that. That's a good one. All right, that's a good one. All right. To do. Future idea. There you go. All right. Make a model that turns any picture into Obama by rearranging the pixels. I like that one. That's great. Jinlu, thank you. Just got my semester plan. It's packed. We got computer vision, data engineering, deep learning, and natural language processing. That's a good one. Somewhere until 7 p.m. That's too late. You've overbooked. Soki, you've overbooked. Not saying that because someone done it already. Oh, they did? Well, we could do it too. We could do it too. It's unfortunate. Hey, it's all good. Check what I put. Link share. Okay. Link share. Oh, you're right. They already did.
I have finally invented an algorithm that turns any image into Obama. It works by taking every pixel in the image and then it literally finds the mathematically optimal way to rearrange the pixels to make them look like this picture of Obama, which is then fed into a fluid dynamics physics simulation that moves the pixels into the perfect Obama arrangement. Now, you might wonder, how is this useful at all? And I wonder that too. So I used it to make this state-of-the-art drawing program that slowly turns whatever you're drawing into Obama. This is really useful because like when you're drawing something, but like when you're drawing you forget that.
All right, that's pretty good.
It's 2 a.m.
You can make something that turns everything into a PubNub logo. Ah, there we go. That would be really fun. I like that idea. Good idea, you guys. Jinlu, that's great. I like that. Very nice. That's great. Oh, that's a good idea. Yeah. Definitely, you guys. Definitely. All right, so before we go today, we're not done yet. Before we go, we're going to print out every single activation function. And we're going to plot it and make it look pretty. That's the plan. NumPy... Oh, wait, no. It will be divided by 80. Yes. X divided by 80. That's it. That's all we got to do. That's it, because it's NumPy, right? Array? Or do we have to say ND array? Is that something like that? I forgot. We'll remember, you guys. Python. There we go. Import numpy dot array. Is that a function? Yeah. Is it nd? Is that another function? It is. What's the difference? 0, 0. Oh. Okay, just regular array. All right. Cool. I don't know where ND array came from. Hey, Loons, good to see you. Welcome on in. Happy Monday. We're doing some Python PyTorch today. We're going to plot every single... I think this is going to work out. All right, so this will be X and Y. X and Y. And this will be called activation functions. Although, I don't know which one's which. I suppose what we could do is... we could copy each of these. And then put them into an array. And we can loop over all of these. Is what we could do. We could loop through every single one. Alright. So this will give us a line, basically. It should be a diagonal line, I believe. Print all activations. Let's try it. Here we go. Print all activations. Yeah. A diagonal line there. It's right there. You guys see? I told you. Diagonal line. I even got the orientation proper. Also, the same guy who made that made a 3D level in Geometry Dash, which is 2D. Oh, nice! I like it. All right, so let's print all the activations. All right, so we've got our X and Y, which is fine. So all we have to do is instead, we're going to say for activation in activations. And we're going to say y is equal to, or x. No, x is always going to be the same. Y is going to be the output, which is the activation. And we also need to go negative. So we should do, let's see here, divide by, we'll figure that out in a second. His name is Sputnik. The guy's made the level. Oh, is he? All right, Sputnik. Another video and link share. Got the advertisement. Okay. Took 2 years to build. What are we looking at? Yay, ads! Yep, we're good to go. Oh, nice. Yeah. Oh, 3D version of this. Yeah, I remember the 2D version. How are you supposed to... Is this a Flappy Bird type thing going on now? Just don't touch any of the edges? This is a bit much. Remember this made in 2D, in the 2D game? I remember the bouncing square. I don't remember this part. Well, I mean, the square where you could hop, where you can choose to jump, and that's the only move you got. It's like a track and it just scrolls across the screen. He also made a programming language for Geometry Dash. Oh, really? That's a bit much. This right here. I recognize this. Wait. Is this... Is this a game that you could actually play? Can you actually play that? Sputnik Geometry Dash. Alright, oops. Alright. That looks pretty interesting. Looks like it's pretty fun. Yeah, he made a map and make millions of objects and animations to make it 3D. That's a lot. That's a lot. It's... Oh, Geometry Dash. That's the Geometry Dash level. Got it. Okay. Good to know. Okay, let's see here. Can we go... Oh, all right. Sounds fine to me. Okay, let's go over here. Okay. Loons, yes? All right, got it. All right, so before we head out, you guys, what we're going to do is we're going to make sure that we get all of our activations plotted. And then we will wrap up for the day, and we will have achieved our objectives to see what each of the activation functions look like from a linear input perspective. We just want to see, we want to plot them out. All right, so activation function, let's see here. So let's do activation, which I believe we need, all right, where's that at? Y is going to be, yeah, it does need to be, okay, perfect, okay. Activation Y. I think. Yeah. All right, let's try it. Let's see if it works. Let's do just the first one. 0:1. It doesn't like that. Why? Where is that problem at? Probably because it needs to be NumPy. Detach. CPU. NumPy. All right, Matt, we got one step closer. Or a step backward. Where's the problem at now? Activation. Object has no detach. How about CPU? Nope. What about NumPy? Doesn't like it. No NumPy? Alright. So then instead of plotting it, let's go into print Y. See what's going on there. That looks fine to me! Why is that not what's going on here? Can we do that? Is that gonna work? Must be a fluke. We're gonna find out. Alright, let's try printing. Float arguments must be a string or real number, not LU. Is that specific? So let's just do... We'll just do that. We'll keep it in sigmoid world. Sigmoid argument input position must be a tensor, not a NumPy array. Okay. We can fix that. Torch.tensor. We will say dtype equals float 32. Try that. It might be because of the... Oh. Got it. Did I type that wrong? Oh, torch. Hey, there we go. All right. Although that is not a sigmoid. That is not a sigmoid, you guys. All right, or it might be. It just we might need to zoom out. That's what we got to do. Yay! All right, we got to zoom out. All right, is that exactly what a sigmoid looks? All right, so that is. So let's do. How do we do this? X. All right, see, it's now it's not enough. Now it's too much. Okay. It's too big now. It's too big. Not to steal too much time, put a video in general and of the books. All right, Jinlu, we'll check it out. And then I do got to head out here. I really want to print. I want to print these activation functions and make them look pretty on the terminal. General chat.
Alright, so here's the 2016 MacBook Pro, and she's seen better days. Oh my gosh, this is like.
That's terrible.
Really,
I can see it.
You got this massive dent in the back, but yeah, if we open it up, you'll be immediately able to tell.
Hey, look at it!
There's a startup chime at least. But yeah, this
That's rough. So it looks like the screen.
Yeah. What can I even think about the screen? It's just, yeah.
Full replace.
You could kind of fix it a little bit of it. You could like press here, and then you like push on the back.
Oh, you can see it. It shows up a little bit. Yep.
Yeah.
The background.
Yeah, you can tell like this is pretty messed up. This is blinking with the login like cursor, the text cursor. But like up here, this screen works fine. You got the
Oh, perfect. You just need that little bit of the screen right there, and you're good to go.
menu up here as well. So turn it off. Like this has functional hardware in here. Also, the touch bar actually still works, but the screen itself is the problem.
That's you, Jinlu. We could see your reflection. That was great. So you've actually, so all you really have to do is replace the screen, and you've got a whole good working MacBook there. A whole good working MacBook. I mean, the hardware should be fine, except the screen, of course, right? Yeah. Means that it should be fine. Don't know about how difficult it is to replace. Is there stuff you got to do? You got to replace some stuff. All right. This is the activation. It is the ELU activation. All right, so let's do. Oh, I need to generate a new instance of it. Okay. I think we figured it out, you guys. The processor and everything works, so likely just the Thunderbolt and HDMI adapter. Oh, that'll work great. That's a good point. You don't even need the screen. Just plug it into a monitor. Good idea. Okay. So I think we can do this now. We could. I'm pretty sure that'll work. Is it gonna work? No! Multi-headed attention. All right. It's this particular one is not gonna work. So here's what we're gonna do: is we're gonna validate this. Make sure it looks good. Weird. That should be working. Missing 2 required potential arguments. Embed. We're not doing that. What did we do? Why has it been weird? What did we mess up? Oh. Some of the activations require things. All right, so we're just gonna skip on some of these things here. Hey, there we go. If you can't restore one, selling it for parts can still turn a profit. Nice. Jin Loop, very nice. All right, I want to see a beautiful sinusoidal or a sigmoid curve. I want to see a nice sigmoid curve. That's what I want to see. I want to see a very nice sigmoid curve. Validate looks good. Validate, yep, all right, good. I want to see a beautiful sigmoid curve before we go to the next step. All right. So that is part way. That's part way. I need to see below 50. I need to see below 50%. Hey, Kyle, good to see you. Welcome on in. B2B, you have a B2B PubNub vertical I need to run by you, Steven, using PubNub. I'll try to send something tonight. Sounds good, Kyle. That sounds great. Looking forward to hearing about it. All right, so the plan is before we head out, you guys, I need to print out every activation function, which we're almost there. We're almost there. So X would be 1. So this is weird. Can we do -80 to +80? Will that work? There we go. That's what I was looking for. All right, this whole time. Look at that, you guys. This end of streams. Dang, I know you. It's the end of the stream. Yeah, you brought it to the very end. We are going to print out each of these. No, I think I got them. No, I think I got them. All right, let's see if we can get this. Before I do, I'm going to see if I can optimize and make it a little bit nicer. Let's make it a little bit nicer. 20. All right, let's try again. Is that better? No, let's try 30. Let's do 5. Okay. No, that's not good. All right. So we gotta go somewhere in the middle here. Maybe 20 is good. Let's try 20, just to see. All right, we'll just stick with 20. Let's go at 15. Get like 50%. Nice. Okay, there. I think we've got a good one. All right, now let's print every single one of them out. Okay. Print. Let's delete that. Oh, well, you know what? I suppose we could print that so you can see what the activation is. 16. Yeah, we got 10 minutes. Let me double check. What's my clock say? We literally have 10 minutes, and then we have to get going. We're gonna make it, though. I know we're gonna make it. No! All right, print all activation functions numpy. Where did the problem at? All right, so log, it happened right. Hey, look at that! Look at that! All right, we're getting good. We almost got all of them. This one's neat right here. Hard swish. Have you guys ever used a hard swish activation function before? Look at that. That is beautiful. It is beautiful. Let me switch the X and Y. See if that looks more interesting. Switch it around. There we go. Now we understand it. Now it looks a lot better. There's the sigmoid, right? That one's sigmoid at the top. I believe, yeah, this is sigmoid. Okay, good. So you get sigmoid at the top, then you've got the hard shrink, then you've got hard sigmoid, which is very hard, right? The very hard sigmoid. And then you've got a hard tangent. You've got a hard swish. Look at that. Whoomp. Very neat. This is great. Leaky relu. Yeah. Log sigmoid. Nice. And then we got an error right after log sigmoid. So let's see if we can see it. Log sig. All right. So this one had an issue. So let's close that out. See if that works now. All right. Hit another one. Right before shrink. Shrink. Right here. Was it gelu? So if I just comment that out, are we going to have success end to end? Hey, there we go. We did it. All right. We printed out every single activation function. This one's pretty. I like this one. Soft sign. Soft sign, you guys. Apparently, yay, we did it. Soft sign is very nice looking. Look at that. That is the smoothest of them all. If you're looking for the smoothest, soft sign, you guys, is the answer. This one's smooth too. Oh, this one's sigmoid though. Of course, we know sigmoid. We know all about the sigmoid. This one's neat, right? Look at that one. Look at this one. See, it's got like all this random noise and then it goes linear. So look at that. That is neat. relu 6. We got version 6. It's the original relu. Log sigmoid. Nice and smooth there. Leaky ReLU. Hey, this is nice. Try GelU. Okay, GelU you said? Okay, let's try GelU. We'll put it at the very bottom. All right. You said called GelU, like that? Oh, it's right here. GelU's right here. All right, we'll put it at the bottom. We'll put it at the bottom again. All right, run. GelU. Ah, nice. Look at that. You see right there? It's got like this little dip. It does this little dip first. Nice. Hey, Dina, good to see ya. All right, you guys, we did it. We succeeded. We printed out. We tried all. We at least printed out each of them, and we drew them. We didn't necessarily use them. We drew them, though. That's pretty great. GLU is based on transformers a lot. Ah, right. That makes sense because we need extra parameters for the transformers. Basically, event-driven architecture using PubNub for a multi-object detection. Ooh, it feels like a live feed, Kyle. I like what you're thinking. I know exactly what you're thinking. It only took me a second. You just realized the 2016 MacBook also has a massive dent in the bottom. Oh, it does. I saw it too. You could see it because it was bent. The keyboard was bent. You could see that it was top and bottom. It was bent. The screen. What are we doing, by the way? Hey, Redless Saber, we just printed out all of the activation functions that are available to us to draw, at least in a simple perspective, in PyTorch. We drew them all. It's actually pretty nice. It's pretty great. Look at all the options. This is my favorite one right here. I really like. It's called Soft Sign. I like that one. All right, right before we head out, you guys, let's try Soft Sign because it's so good looking. It's so good looking. I don't know if it's gonna work properly though. The poor MacBook beating, yeah, probably because of the keyboard issues. Oh, sad. It was sad. You see where I'm going with this? I sure do, Kyle. Yep, that's what I'm gonna send. All right, sounds good. Looking forward to it. All right, so I want to try the, what was it called? It was called Soft Sign, right here. Let's try this one. Let's see if it looks good. Soft Sign. All right, Soft Sign. And then we're gonna activate this. We're gonna run the XOR model. So let's do the train. All right, let's do this. We'll say def, or no, or just run train. Train as you do. Okay, running the train. Let's see if we get a bit interesting answer there. Oh, wow. Oh, I was not expecting that. Oh, because we printed the loss. Right, okay. So we need to increase our learning rate. Learn is going to be that. Okay. Is it going to learn? Oh, we got a problem. All right. Maybe we made the learning rate too big. Ooh, what really? Okay, what do we do? What happened? Did we do it? Oh, maybe we never, hold on. What happened? No, we did it. We actually got it working. See, it worked once. It worked one time, you guys. What happened? What do we do? We broke it. Oh no, we got to get going, you guys. Let's see. Okay. So you guys, it was a lot of fun today. We got back into Python. We got back into PyTorch. It's good to have you guys back. We will be doing more PyTorch tomorrow. We will be getting into a new project, and we're gonna have a lot of fun with it. We're gonna do AI. That's the plan. The plan for the next month is AI. Thank you for the hearts, you guys. Good to have you here. We're gonna wrap up. I would really much like to fix this real quick. I would love to see this fixed. What did we do? Where is the activation at? Let's go up here. Let's go back to Sigmoid. Was that really the problem? Oh, we had it at Sigmoid the whole time. Okay. So the soft plus, we got to do something different. All right. Oh, well, we got it working now. Let me go back to the learning rate. Let's drop this back up there. And then we should see it. Yeah, there we go. Nice. Looking good. Okay, you guys, thank you so much for hanging out. We got to head out now. Had a lot of fun today getting back into PyTorch and Python. Took a little bit getting used to. I was doing some of the JavaScript comments, and I was like, oh, we're in JavaScript. This took a little while to get back to used to it. But now we're back into Python and PyTorch. It's been a pleasure. Torva, thank you. Torva, good to see you. We'll be back tomorrow, you guys. Heading out now. And Jinlu, good to see you. Kyle, good to see you as well. Redless Saber, good to see you. We'll head it out now. We'll be back tomorrow. Back tomorrow with more Python, you guys. More Python. And then Neva. Also, Neva, it was great to see you, Neva. And Dina. Dina as well. Good to see you as well. Thank you for stopping by, you guys. Back tomorrow. All right. Hope to see y'all tomorrow. Have a great rest of your day. Seek the vault. Thank you for the hundreds. Thank you for your actions, you guys. We're headed out. Back tomorrow. Great stuff. Yep. Thank you, guys. See you tomorrow. Lindo Kohaza. Good to see you guys. Neva, bye. Bye, everybody.